Welcome back, geometry thinkers. Today's TEK is G2B. Derive and use the distance, slope, and midpoint formulas to verify geometric relationships, including congruence of segments and parallelism or perpendicularity of parts of lines. Now, this video deals with calculating the endpoint when given another endpoint and the midpoint. Our learning objective is to calculate the endpoint when given an endpoint and a midpoint, and you will know you have mastered this objective when you can calculate the endpoint when given the other endpoint and the midpoint. Every step you take and every skill you learn makes you stronger. I know you can do this, so let's turn your practice into power. In the last video, we located a midpoint when given two endpoints. This is an entirely different situation because now we're going to find the coordinates of an endpoint when given the other endpoint and the midpoint. An example problem would be, find the coordinates of point J if K with the coordinates of -1, 2 is the midpoint of line segment JL, and L has the coordinates of 3, -5. Our first step is to get the midpoint formula for the coordinate plane, which is m equals x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. This formula is very important. Next, we draw the situation described by the problem. We know that we have line segment JL. So I literally draw line segment JL, and I put J as one of my endpoints and L as the other endpoint. In the problem, it tells us that K is the midpoint. So I make K the midpoint of this line segment. I fill in the information given to us in the problem. So I know that the midpoint has coordinates of -1, 2. I know that L, right here, has the coordinates of 3, -5. So the endpoint that we're looking for is J, right here. I have no idea what the X and the Y values are for this coordinate, and that's what we have to calculate. I am next going to choose my endpoints as endpoint 1 and endpoint 2. I will make J my x1, y1, and I will make L my x2, y2. So I bring down my midpoint, which is -1, 2, and then the formula tells me to add my endpoint x values, divide by 2, and my endpoint y values, and divide by 2. So I'm going to take my x1 and add it to my x2, which is 3. So I get x1 plus 3, all divided by 2. And now I'm going to take my y values, which is just y1, and add it to my y2, which is a -5, and I'm going to divide that by 2. Separating these into two separate problems, I get a -1 here is going to be equal to this algebraic expression. 2 is going to be equal to this algebraic expression. So now I have two problems, two equations that I need to solve for x1 and y1. So I'm going to take the -1 equals x1 plus 3 divided by 2, and I'm going to bring it down here. I'm going to take my 2 equals y1 plus a -5 divided by 2, and I'm going to bring that down here. So let's focus on the left-sided problem. So I'm going to take my -1 equals x1 plus 3 divided by 2, and I'm going to solve for the variable, which is x1. we need to get rid of the denominators, and the easiest way to do that is to multiply by the denominator or a common denominator. Since the common denominator or the denominator itself is 2, I can just multiply both sides by 2. Now notice the way I solve my equations. I actually change the color. You're going to see the things that change from the first step to the second step are going to be done in a different color. So I'm going to multiply the left side by 2 and the right side by 2. Why do I do that? Because I want to get rid of this 2 in the denominator so we can ultimately solve for this x1. So I multiply both sides by 2. A negative 1 times 2 is a negative 2, and that's going to be equal to the 2 in the denominator and the 2 in the numerator. These two cross out, and what's left is only the numerator, which is an x1 plus 3. So I have negative 2 equals x1 plus 3. Now remember, the goal is to get x1 by itself. So what's happening to x1? We're adding 3. What's the opposite of adding 3? Subtracting 3. So I'm going to subtract 3 from the right, but if I subtract 3 from the right, to keep this balanced, I have to subtract 3 from the left. So I do exactly that. I then move to my next step and simplify. A negative 2 minus 3 is a negative 5. The 3's cross out over on this side, and all that remains is that x1. So I end up with negative 5 equals x1. I'm going to flip it and say that x1 is going to be equal to a negative 5. And so we just found this value right here, x1, that is negative 5. So let's move over to that second half, the y1 values. So I'm going to pull that equation down, and I'm going to get 2 is equal to this. So 2 equals y1 plus a negative 5 all over 2. I want to get y1 by itself. In order to do that, I need to get rid of this and this. And so we're going to start with the 2 first. So just like in the other example, we're going to multiply both sides by 2. I'm going to multiply the left side by 2 and the right side by 2. Because whatever you do to the left, you have to do to the right. Whatever you do to the right, you have to do to the left. Because we have to keep these equations balanced. So notice again, everything from the previous step is in this pinkish color, and everything I'm doing to undo to get that y1 by itself is in this dark blue. So the 2's cross out on the right-hand side, and what remains is the y1 plus a negative 5. I have 2 times 2, which is 4, and the y1 plus a negative 5 moves down. So now I have simplified that equation into 4 equals y1 plus a negative 5. I ask myself, what's happening to y1? I'm adding a negative 5. What's the opposite of adding a negative 5? Well, that's subtracting a negative 5. So my next step to get that y1 by itself is to subtract a negative 5, and if I subtract it from the right, I have to subtract it from the left, just to keep the equation balanced. So now we end up with the negative 5's crossing out on the right-hand side, and the only thing that remains is this y1, which carries down. So we're going to simplify 4 minus a negative 5. You know that when you subtract a negative, it turns into an addition problem. So instead of it being 4 minus a negative 5, it now becomes 4 plus 5. 4 plus 5 is equal to 9. So y1 equals 9. I'm going to flip it around, and I have y1 equals 9. So we have found our x1 and our y1. We're going to put them together to form a coordinate, and so, or a location. So I'm going to piece them together and I get my -5 in my X position and a 9 in my Y position. So the answer is -5, comma 9. This is X1, Y1, or this is point J. -5, 9. Now it's your turn to take the lead. Let's see how you can apply what we have just learned. The instructions for this problem read, find the coordinates of the missing endpoint if B is the midpoint of line segment AC. We know that the coordinates of A are -4, 2. For the midpoint B is 6, -1. And they want you to find the coordinates of C. Remember to show all of your work in your notebook and be sure to box in your final answers. Your written work should clearly show your thinking so that I can follow your logic step by step. Now, if you have any questions or issues, please ask. You may check your answers on the next slide. Now, please pause the video and complete your work. When you are finished, press play to continue. Here's the answer to the problem. Now please pause the video and check your answers. There are actually 2 slides that show you the answer and the work for today's problem. So make sure that you pause for the first slide and then pause for the second slide as well. When you're finished, please press play to continue. Here's continuation of the work from the previous problem, and you'll notice that the final answer is 16, -4. This is it for today's video. Now, if something doesn't make sense, that's your cue to ask questions. Please know you can come to me, you can visit with your classmates, or even try AI for step-by-step explanations. We are all here to help you succeed. You learn best by breaking concepts down step by step and skill by skill. You are turning your practice into power. I believe in you and I know you can do this. You are on your way to success.